Okay, let's go through Chem number 15. And this is talking about some more trends on the periodic table. And these are called ionization trends. So one thing you want to notice about that word is at the beginning of ionization is the word ion. So you should notice this word right there, ion. An ion is basically an atom that has a charge. Okay, information. Separating charges. Examine figure 1 below, where there are 3 pairs of metal spheres that have different amounts of charge on them. The spheres in diagram C are closer than the others because they have the strongest attraction. So let's look at our diagrams here and see what we can analyze. So it says the spheres in diagram C has the strongest attraction because the spheres in diagram C are closer than the others because they have the strongest. So they're closer because they are the strongest. And notice that they have a +7, -7. Whereas this one has a +3, -3, and they're far apart. +4, -4, and they're getting closer together, but not as close as the 7s. So let's look at our first question. Which would be harder to separate? The 2 spheres in diagram A or the 2 spheres in diagram B? And once again, it wouldn't be science unless we say why. So we can say that diagram B would be harder to separate because the force of attraction is greater due to the higher charge difference, and they're also closer together, which was probably an obvious reason there. All right, let's look at question number 2. It says draw Bohr diagrams for lithium, nitrogen, and fluorine. So we have 3 Bohr diagrams to draw. So the first thing you have to do is go to the periodic table and find out how many electrons do these elements have. Okay, so when we look at the periodic table, lithium has 3 protons, so it has 3 electrons. Nitrogen has 7, and fluorine has 9. Okay, so there are the 3 Bohr diagrams for lithium, nitrogen, and fluorine. Number 3, for each of the atoms in question 2, compare the attraction between the nucleus and the outer level electrons. Which atom has the strongest attraction between the nucleus and the outer electrons? All right, so when we look at these 3 elements, you can see that fluorine has the strongest attraction. It has more protons in the nucleus. It has 9 protons in the nucleus. The outer ones feel a +7 because it's blocked by those 2. But nitrogen, the outer ones only feel +5 because its +7 is blocked by those 2. And lithium's outer electrons only feels a +1. So fluorine has the strongest attraction. Number 4, which would be more difficult if you wanted to remove an electron from an atom of fluorine or from an atom of nitrogen? So the answer would be it would take more energy to remove the outer electron from an atom of fluorine than nitrogen. And the reason why is pretty much what we're saying up here. Because fluorine's outer electrons are feeling a force of +7, whereas nitrogen's is only feeling a +5. So it'd be a little bit easier to take nitrogen's. So the more difficult one would be fluorine. Number 5, would it be easier to remove an electron from lithium or nitrogen? So it's going to be the same thing. You're looking at this charge here that the outer electrons are feeling. So if 5 protons are trying to hang on to those outer electrons and only 1 is trying to hang on to that or given a force of that, what would your answer be? So our answer would be, it would be easier to remove from lithium because lithium's outer electrons experience a weaker force than nitrogen does. Okay, so let's read about ionization energy. The amount of energy that it takes to completely remove an electron from an atom is called ionization energy. So this is definitely something you want to highlight because it's something you need to know. What is ionization energy? The amount of energy it takes to remove an electron from an atom. We have a first ionization energy. That's the energy required to remove one electron from the atom's outer energy level. Then we also have a second ionization energy. That's the energy to remove the second electron from the energy level. The second ionization energy is always higher than the first. Why? Because noble gases have 8 electrons in their outer energy level. They're very stable, and therefore it takes a very high amount of energy to remove an electron from a noble gas. Plus, another reason I would think as well is that there's just a stronger force trying to hold on to that electron. You took one away and the atom's holding on stronger to that second one. So let's look at our question. Which would have a higher first ionization energy, phosphorus or aluminum? All right, so we need to go to the periodic table and let's see how many electrons those two have. So when we look at our periodic table, we see that aluminum's got 13 electrons and phosphorus has 15. Okay. So aluminum has 13 electrons and phosphorus has 15 electrons. So phosphorus has a pull of 15 electrons in its nucleus. So we can draw the Bohr model if you need to. We've got plus 13 in the middle. You've got 2 in the first energy level. Then we're going to have 8 in our next one for a total of 10. And then our last energy level would have 3. And phosphorus is going to have the plus 15. 2 in the first one. 8 in our next one. The next energy level. So that's a total of 10 right now. And then we're going to need 5 more. Okay, so phosphorus would have the higher first ionization energy because it has a higher attraction between the nucleus and the outer electrons than aluminum. Phosphorus has a plus 5 and aluminum has a plus 3. All right, number 7. Phosphorus and aluminum are in the same row of the periodic table. Lithium, nitrogen, and fluorine are also in the same row. Using your answers to questions 3, 4, and 6, what do you notice about the ionization energy of elements proceeding from left to right across a row of the periodic table? Does the ionization energy increase or decrease as you go across a period? So as we move from left to right on the periodic table, ionization energy increases. And so that's something that we need to know. That's the pattern that we need to know. As we move from left to right, ionization energy increases. And then, of course, our why. Why does this trend exist? So the why is because the attraction between the nucleus and the outer level electrons increases as we go across a row. There is a stronger attraction on the outer electrons, making it harder for them to be removed. Draw a Bohr diagram of sodium. Do you expect the first ionization energy to be high or low for sodium? So sodium has 11 electrons. I got that from the periodic table. So there's my Bohr diagram. So sodium has a low first ionization level. It only feels a +1 from the nucleus. So it's pretty easy to take that electron that's out there. Now, if we were to try to get from the 8, that'd probably be a little harder than that one that's out there by itself. Question 9. The second ionization energy of all elements is higher than the first ionization energy. But in sodium, the second ionization energy is extra large, and that's what I was talking about, is that second energy level is full. So it will be a lot harder to take that electron. Considering the structure of sodium atom that we drew on the other page, explain why this might be. Hint, after one electron is removed, what is sodium's electron arrangement like? And so sodium, it had 2 in the first energy level and then 8 in the next one. So it's very similar to our noble gas. The noble gases do not like to give away their electrons. So after the first electron is removed, sodium then has the same electron configuration as neon with 10 electrons. At this point, we're very stable, and it's much harder to take an electron away. Question number 10. A certain atom in the third period has a third ionization energy level that is really high. Using the same reasoning you used for question 9, who is this atom? All right, so we need our periodic table, and it said a certain element in the third period. So this is our third period right here, sodium, magnesium, has a third ionization energy level that is really high. So I have to think here. Magnesium has 2 electrons in its outer circle, the outer energy level. There's 2 electrons sitting there. Okay, so I'm not going to draw the whole thing. So we can get rid of these 2 electrons, but then if we try to get the third, the same thing as sodium. It now has a noble gas configuration, and that is very hard to remove. So magnesium is the answer. It's in the third row. It has 2 electrons that are easy to remove, and then when we try to remove the third, it's going to get very hard because at that point it has a noble gas electron configuration, which is what elements want to achieve, and so therefore it gets very hard to remove. All right, we got some more information. Trends in ionization energy in groups. So now we're going to talk about the group as we go up and down on the periodic table. So we've got a couple things to look at. Consider the following figure of diagrams. They're magnets, so these are closer together than these. And if you've ever played with magnets before, you know the closer you get them together, the stronger the attraction. And it's harder to pull them apart, especially when they connect, especially if you have really strong magnets. So let's look at our question. Would it be easier to separate the magnets in diagram D or E? Okay. Assume that each magnet is attracted to the other and that the size of attraction is the same. Take only the distance between the magnets into consideration. So it would be easier to separate diagram E. They're further apart, so the attraction is not as strong. So how does the distance between the outer level electrons and the nucleus in phosphorus compare to the distance between the outer level of electrons and the nucleus in nitrogen? So we want to look at the periodic table. Nitrogen is above phosphorus. Nitrogen is a smaller atom. Phosphorus is a lot larger. So the distance between the nucleus and the outer level electrons is greater in phosphorus than in nitrogen. So phosphorus is the larger atom. The distance between the nucleus and the outer level electrons is greater in phosphorus than in nitrogen. So 2 more questions. Question 13. Based on your answer to question 12, would it be easier to remove an electron from nitrogen or from phosphorus? In phosphorus, the outer electron is further away from the nucleus, so it's not feeling as strong as a charge. So it'd be easier to remove it from phosphorus. So we could say that it's phosphorus because the outer electron is farther away in the phosphorus atom than in nitrogen. Question number 14. Nitrogen and phosphorus are in the same column on the periodic table. So now we're going to try and find the pattern. From your answer to questions 12 and 13, what is happening to the ionization energy as you move down a column in the periodic table? And this is the question that's going to give us what we need to know. So we need to write this very carefully. Okay, so as we move down a column of the periodic table, ionization energy decreases because the size of the atom increases. So that's the point that you need to remember. So you are now ready to do skill practice number 15.